Okay, so today's really the official first day of calc, right? This was all pre-calc, a little bit of review. Did the review help a little bit? Warm you guys up a little? Okay. Anyone curious what calc is about? Or anyone thinking, now let's do more pre-calc. We don't have to do anything. Okay, so we'll start on the first section. We'll only do one section at a time. The first couple of sections are long though, so. Okay. Okay. This is section 2.2. Hiding the image here. Okay. All right, so section 2.2, something called limits. Okay. Okay, so here's the idea, right? We have a function and we studied its domain, right? So suppose we have a domain of a function where x is not equal to 1. Right. Right. So what do we do? In other words, if we're missing something in the domain, what we try to figure out is what's happening near 1. Like we can't plug in 1 because it's not in the domain. That means this function is undefined. There's something going wrong at 1. So we're missing information of this function, right? We could have functions where we're just missing information. Either because we don't have the experimental data, that's why we're missing it, or the function is just undefined as a function. There could be lots of reasons. So what limits try to do is we're going to figure out a way to kind of extract that information at 1. That even though we can't plug in 1, we'll still have a really good understanding of what the function is doing close to 1. So here's what I mean. Maybe it looks something like this. So 1, comma, 4. Let's say there's an open circle. It's really not in the domain. And then the rest of the function looks like this. Okay, so we're missing a data point. But do you guys see, even though we're missing a data point, we could still predict what would happen when x goes to 1 or gets really close. See, if x is going towards 1, look at these y values. The y values are here. If x is going towards 1, notice how the y values start increasing for this function. They're going up. What y values are getting approached as we get closer to 1? Like picture, pretend like you're standing here. Pretend like you're really like going on a hike. And you're climbing up. You don't know what happens at 1. You don't know what your height will be, but can you predict what would your height be if you get all the way to 1? I mean, I guess you'll technically fall off, and hopefully there's some padding here that will catch you. But what height will you be when you fall? Matthew? Right. 4. Do you guys see that? That if you keep walking, the point is not there, but at the point where you fall, your height is going to be 4. So what we say is, that the limit, we write limit, as x goes to 1 from the left, meaning this hiker is x. You could think of x as your hiker. And he's approaching 1 on the left side of 1 of f of x. See, we can't plug in once. We write the word limit. And we say what his height will be when he falls off. What will his height be? 4. 4. So that's what we say. We said that the limit as x goes to 1 from the left is 4. Right. So x is not in the domain. We're lacking info, but we could still kind of predict what'll happen as we get close to 1. We're getting close to 4. Does that make sense, guys? Like a little intuition. Yeah. So this minus is like it's not really a minus. I'll call it like mathematical lazy notation, where mathematicians, instead of writing out the word left, we don't want to write the word left each time. We just decided a little dash will mean left. So it means 1 from the left. Meaning that you're starting to the left of 1 and you're getting close to 1 in terms of the x direction. Yeah, so it's not really a minus sign. It's our lazy way out. Let's put it that way. Okay, good. What if the rest of the function was, let's say, something like this? Now, what if the hiker was on the right side of 1? Right. He doesn't know what'll happen, but he does want to get close to 1. He wants to kind of peek over. He wants to know what's happening at this mountain. And if notice how the guy traveling, if he starts on the right and he's going towards 1, notice how his height starts decreasing. What will his height be when he falls? 4. It'll be 4. Rachel, right? Rachel. His height will be 4. So notice his height will be 4. So we say, the way we write that is that the limit as x goes to 1 from the right, so plus sign is the notation we say to the right. Right? It doesn't mean positive, it just means right. So again, our lazy way out. Okay. Of f of x is equal to 4. Okay. Equal to 4. That's what we say. So the hiker starting from the left will get up to 4. The hiker from the right, when he approaches 1, will get down to 4. So they're both reaching 4. Okay. So limit as x goes to 1 from the right. Okay. Just so you understand, these values here, the value after the equal sign, you should think of it as y values, right? We're measuring y values, right? Normally, we just want to plug in 1, but we're not allowed to. It's not in the domain. We can't plug it in. We don't know what it does at 1. Okay. In fact, maybe this function's kind of crazy where it does this and like f of 1 is up here. This would be a case where 1 is in the domain, but it's up here. But still, in terms of limits, in terms of the hiker, what's going to happen to him when his x coordinate gets to 1, he'll be at 4. And this hiker, when his x coordinate gets to 1, he'll be at 4. This value doesn't matter, right? So limits are kind of predicting what's happening left and right. right? They're detecting a pattern, right? You're looking at the pattern of y values on the right. You're looking at the pattern of y values on the left. And you're predicting that pattern for those y values. So these y values are going towards 4. Notice that they match. They don't always have to do, but they match. The left and the right match. So when the left and the right match, when they match, we say that the actual limit as x goes to 1 of f of x is equal to 4. Okay. So the way you should think of a full limit is only when you have left and right. So I should really maybe draw like arrows on both sides. Is when you look at the heights from the left and the right, and they both predict 4, they both predict the same number, that's when you have a limit. That's when you have a limit, when left and right predict the same number. If left and right predict different numbers, we'll see what happens. We said that the limit does not exist, right? So having a limit means left and right predicting the same number. Okay? It has to go to the same number from the left and from the right. Okay? I'll show this numerically in a second, but any questions on this? This is just sort of an intuitive little thing with limits. Okay. Another way you could maybe picture it is like if you're watching like a football game and it's time, and let's say this is like the number of yards, and you see the guy running with the football, like you're watching it, he's getting to, I guess, I don't know, 3-yard line, 3.5-yard line, but right at time 1, you have like some interruption, the TV goes blank just at that second. So you see the guy running here at time just less than 1. At time 1, you don't know what happened, right? The TV goes blank, electricity went out. Then right after 1, you see the guy running with the football up here, going further yards. And we're asking, like, can you predict, like, what yard line was the guy with the football at time 1? I know the screen went out, but you saw where he was right before, and you saw where he was running right after. Can you predict where he was at 1? And that's really what like a limit is. A limit is filling in the missing information that you missed out on. Right. Right. Anyone ever watch a good game and right at the best part, like you get a phone call that you have to take, an annoying phone call. You don't want to pick it up, but sometimes you just have to. Okay. You could miss some information. Here's another way to look at limits. Here's a more concrete way. So let's do this numerically. Let's have an actual function. So f of x equals x squared plus 2x minus 3 divided by x minus 1. So again, what's the domain?
All the real numbers except 1.
All real numbers except
1.
X can't be 1, so we're missing info. We don't know what the function does at 1. Okay. Right. But we're going to predict it. We're going to predict what the function is going to do based on the pattern with limits. Okay. Okay. This will help us understand this function better. So if you plug in f and f of x, let's say you put into your calculator. So I want to know what happens a little bit to the left of 1, a little bit to the right. I want to get close to 1. I'm going to plug in 0.9. I put it into the calculator. You could do it, and you'll get 3.9. I'll get a little bit closer, 0.99. Right. You plug it into the calculator, you'll get 3.99. Okay, let's see. What if I get even closer to 1? 0.999. I can't plug in 1, right? Try plugging in 1, you'll get an error. The calculator will give you an error. I plug in 0.999, the output is 3.999. Right? Can someone guess what'll happen if I plug in 0.9999? 3.9999. Okay, enough's enough, right? I think we see a pattern,
Infinity.
right? Can someone predict if X is getting really close to 1, what's happening to the Y values? What's the pattern?
It's getting close to 4.
It's getting closer and closer to
4.
4, right? So again, we say that the limit as X goes to 1 from the left, because we're looking at, it's not a negative sign, looking at X values to the left of 1, of f of X, that limit is 4. Okay. Right, so just remember, the numbers here are Y values. 4 is Y values. On the bottom below the limit are the X values that you're looking at. X values here, Y value. How about on the right? We have X and f of X.
1.1.
Okay. 1.1. We're going to put in number 1.1. If we plug it in, you'll get 4.1. 4.1. Okay. Not so far from 4. How about 1.01? Plug it in, you'll get 4.01. You plug in 1.001, 4.001. Okay, so limits are about making a prediction. So if X is getting really close to 1 from the right, what's going to happen to the Y values?
It's also really good.
You're getting closer and closer. 4. Right, they're getting closer and closer to 4. So again, we say that the limit as X goes to 1 from the right, of f of X is equal to 4. So what does that help us do? That helps us understand what this function is doing, right? The left and the right limit means that at 1, it's not part of our domain, but we do know that whatever this function is doing, the Y values are getting close to 4 on both sides. Okay. We don't know the rest of it. For that, we could plug in numbers and figure it out, but we at least have an idea, left and right, the Y values have to be approaching 4. What I mean approaching 4 is when you move this way. So again, you should think of this hiker walking on the graph. He's gonna fall. Okay. Now, what does it mean? Notice how they match, right? They match here again. Left and right match. So say that the limit as X goes to 1 of f of X is equal to 4.
Yeah.
Right. That's if they match. If left and right don't match, if they don't match, then limit as X goes to 1 f of X is DNE. It does not exist.
Look.
And what does it look like if it doesn't match? Well, the way it would look like is that if you had, okay, What's the limit from the left as x goes to 1? 4.
Mhm.
Okay. But suppose the function does this. Now the hiker is here and he's walking towards 1. This hiker, what will be his height when he falls? As he gets close to 1, 6, right? So this one, the limit as x goes to 6 from the right, plus sign just means x goes to 1 from the right, is 6, and then the limit as x goes to 1 from the left of f of x is 4, but do they match? Right? Do the left and the right match?
No.
Right. Right, they don't match, so limit as x goes to 1 of f of x, you're going to have to write dne. It does not exist. Right, having a limit means matching from the left and the right. Right, that's what it means. Right, it's not a separate question of like, okay, I have to do the left, the right, and how do I do the regular? No, the regular is asking if the left and right match. That's what it's asking. Okay, that's what it means. Okay. A question on this, guys. Does this kind of make sense a little bit? Okay.
So yeah, this one.
Right, so that's what we're trying to do with these limits. Let me give you another example just so you see. Just another example. Suppose h of x, let's make it piecewise, x squared plus 2x minus 3 over x minus 1. If x is not equal to 1, that's the function that we just had. Okay. And otherwise it's 2 if x equals 1. So if we were to graph this, then what it would look like, 1, 4, it actually does look like a line. Right, that's when it's not equal to 1. This happens to be a line, x is not equal to 1. You could actually simplify it by factoring the numerator. And then when you add 2, if x equals 1, the output is 2, is like this. Okay. Now, think about it. Let's say we ask, what's the limit as x goes to 1 of h of x? Now remember, when we ask for a limit, we're not plugging in 1. We're asking, what's the pattern left and right going towards 1? Take a minute, think about the pattern. Don't plug in 1. Just look at the pattern on the graph. What's the limit? It's still 4, good. Why?
Because even though like, it says that at 1, 2, it doesn't have 2 sides to 2.
That's right, good. Right, it doesn't have 2 sides to bring it to 2. But when you look to the right and the left of 1, that means the hiker is standing here or here. And if you look at his pattern on left and right of the graph, it's going to be 4. Okay. So the limit is still 4. Left and right, his limit is going to be 4. But what is h of 1? If I actually plug in 1, in this case, 1 is in the domain. So the output is 2. Output is 2. So the limit does not have to match the function, right? The limit is predicting what the function is doing based on left and right. Okay. Okay, so I'll write down the, I guess, the more mathematical definition, but it's just going to match your intuition. So the definition is that we say that limit of f of x as x approaches a is just a number from the left equals L. So i.e. the way we write it is limit as x goes to a from the left. Again, it's not a minus sign. F of x equals L. What does that mean? It means that as x gets really, really close to a, like super close, like really, really, really close to a from the left, then the y values, then f of x gets arbitrarily close to L. Okay. F of x might reach L or it might not. F of x might reach L. Okay, so here's a little picture. What this looks like is here's A. A is represented. The bottom thing here is the x value. Thing to the right of the equals is the y value, L. F of x, right? As x gets closer to A, the y values are approaching L. They get super close. How close? As close as you want, really. Really, you know, if you say like, oh, can I get within 0.001 of L? Yeah, sure. Just bring x closer to A. You can get as close as you want to L. Could it reach? Sure. It could even be a closed circle here. It doesn't have to be an open. So either way, what it does above doesn't really matter because we're looking at the left. Okay. And then similarly, if you want to do the limit from the right, limit as x goes to a from the right, f of x equals L. So x gets super close to a from the right. So if x gets super close to a from the right, then the y values, I'll say then f of x gets really close to L. And that's the right limit. So the right limit, so here would be L, the y value, here's A, the x value, and then the y values are getting really close to L from the right. The hiker on the right is getting his y values, his height, getting very close to L. What it does later doesn't really matter. Okay. But it's predicting what happens on the right. if we have a match, we have a match. That means limit as x goes to a from the left is L. And limit as x goes to a from the right is L. Then we say that the limit as the regular limit, it exists. The actual limit exists. And this would be the picture. Here's A, here's L. Okay. Where the pattern, the Y value pattern from the left and right are the same. Y values from the right get close to L, Y values from the left also getting close to L. Okay, definitely a mouthful. We're going to do some examples, but any questions on this? This is the definition. This is actually not even the full math definition. You want to know the full math definition. It's in the book, but it's pretty bad. We won't get into it. Okay. We need the full mathy definition if you want to do proofs, but since we won't do proofs, I'll leave it out. Of course, if anyone wants to see it, I'll show it to them. Not in front of the class. I don't want to scare people away on only the third day. Okay, is this already scary or still okay? Are you guys with me so far? Yeah, it's still okay? Okay, so what is this section about? I'll say it this way. This section is, we're going to be doing limits, section 2.2, just pictorially. We're just going to look at graphs, and we're just going to do limits by looking at a graph. Okay, the other sections will do limits more algebraically, with doing algebra with the function, but here we'll just do it by eyeball. You know, we'll just scan with your eyes. You'll imagine you're hiking that mountain. You'll imagine the pattern of the heights that you're going towards. Okay. First example, let's do another example. Okay, how about this one? Okay, so this function, f of x is equal to 0 for x less than 0, and it's equal to 1 for x greater than or equal to 1. So here's 1. This is how you graph it. And then 0 is here. Okay, so what will a question ask you to do? The question will ask you, tell me the limit as x goes to 0 from the left. Tell me the limit as x goes to 0 from the right. And then tell me the limit. Yeah, so I'll give everyone a chance to, take a minute, see if you guys can do it. Remember, if you're looking at the left, let's color code it. Remember the one on the left, this one means you put your hiker, you could imagine he's standing on the graph. And where should he walk? He's standing on the left. This limit as x goes to 0. So where should he walk, right or left?
Right.
He should walk to the right. Predict his height. Then for this one, x goes to 0 from the right. Where is the hiker standing? He's standing here. This is where the graph is on the right. And where is he walking?
Left.
Walking here. Predict his height. Okay, so take a moment to get everyone in.
Yeah.
See, Matthew, you had a question or an answer? Okay, we'll just wait like 30 seconds.
Let's just say. Let's just say.
Okay, yeah, Matthew, what about this one? The x goes to 0 from the left. What is it? 0, because what's his height when he's walking? 0. Good. What about 0 from the right? What's your name? Agate? Yeah, what 0 from the right? 1. Right, that's his height. What about the full limit?
Define,
Undefined, why?
because they don't match.
They don't match. That's it. That's what it means to take a full limit. It's just a question of matching. Right? Anytime you see limit and you don't see the minus or plus left and right, it's just a question about matching. That's what they're asking. Does it match? Okay. So you have to put DNE here. What if they make it a little bit of a trick question? Limit as x goes to 2 of f of x. F of x goes to 2. Yeah. Good, good. You'd have to do left and right. So here's 2, left and right. And then what would happen? What would be the height left and right? Still be 1. Right. So limits are only interesting if there's like a breakup or like a hole, then something fun happens. But if your function's actually like defined, it's what we call continuous. There's no breakage of any kind. There's no holes of any kind. Then the problem's actually easier. Then the limit is just whatever the value is, which is, okay. So don't get thrown off by that. If you see like, oh, limit of x goes to 2, there's no hole there. What do I do? It actually makes your problem easier just because there's no hole, then the pattern is, whatever the function is. So, the function is actually defined. Okay, good. We'll do more examples, but Jackie?
So you can have like a limit equation even if the function provides you the point. If that makes sense.
Even if the function goes through the point? That's right. Yeah, you can ask for a limit of any value. And if the function goes through the point, and it's what we call continuous, it's going through without jumping, then you could actually just plug in 2, output 1, and that's going to be the answer. Right? Because then we don't even have to predict the pattern. Like we have full information. So this is like the kind of limit where, these limits, we have to predict the pattern. We're missing information. But when we have full information at x equal 2, we don't even have to predict. We know exactly what's going on from both sides. Yeah. Layla? Oh, you're right. Yeah, why did I write that? Yeah, greater than or equal to 0. Yes. I could have written x greater than or equal to 1, but then my graph wouldn't match. So good, to make it match, it really meant 0. You guys see on this side? Yeah, Sneha, do you see it? Yeah. Is it hard to see? Is this blocking? It's the computer screen? Let's see if we can move it. Is that more visible? No. Maybe that does. Then I can't really, I don't want to drop it. That's the idea. Okay. You see it better from there? Okay. Okay, there's got to be a spot. Okay. But all these notes will be available. So if you wanted it, you'll be able to take them. Okay, let's try another one. This one. Is f of x equals 1 over x. If x is not 0, and it's 0 if x equals 0. Okay, so it goes through here. And then the graph of 1 over x looks like this. So then the limit as x goes to 0 from the right of f of x. Okay. Now this one's a little bit trickier. 0 from the right means, plop the guy on the graph, right? The guy is sitting on the graph and he has to approach 0, right? So he's walking on the graph. He's walking here. Notice his y values are increasing. So what's happening to his y values?
Increasing?
It's going way up too.
Infinity.
Does it ever stop?
No,
Right, it doesn't actually stop, right? There's an arrow here. It's never actually stopping. He'll just keep hiking forever. He'll never make it to the top. So if that happens, you could just put infinity. Let's see more examples of that, but if that happens, just put infinity. And take a second, try to do 0 from the left. Plop the guy on the graph,
Negative infinity.
have him walk to the right. What is it? Did someone say an answer? Is it back up? Yeah, you're saying that if a guy's standing here and he starts walking, right, he needs to walk in the direction of 0. Remember, x goes to 0 means he's walking in the direction of 0. So he does have to walk this way, but what's going to happen to him? Poor guy. It's going to go, where is he going?
Infinity.
Yeah, way down. What are his y values?
Negative infinity.
Negative infinity. Yeah. Do you guys see how they're getting really negative without bound?
Yeah.
Just keep going and going. We're going to write negative infinity. What about the actual limit? The actual limit is a matching game. Do they match? Yeah.
Does not exist.
It does not exist, but more specifically, yeah, they don't match. Infinity and negative infinity do not match. So D and E. What if they did match? What if they were both infinity? Infinity, right? What if they were both negative infinity? Negative, yeah. So the regular limit is just a matching of the left and the right. That's what it means. Have to look left and right. What is f of 0? How about that? What is actually f of 0?
0.
Go ahead.
0.
0. Yeah. You could either do that on the graph with that point, or x equals 0 output is 0. Okay, let's do another weird one. Okay, I want you guys to see like the oddball ones, just to get him out of the way. Okay, here's a real oddball. F of x is 0, x greater than or equal to 0, or x less than or equal to 0, and then sine of 1 over x for x greater than 0. Now, notice that if I plug in small x values like 0.1, 0.01, now 1 divided by small numbers is going to give me really big numbers. So then sine of really big numbers, well, sine of really big numbers could be anything, right? Sine is just a wave. So I could pick a big number to be at the top of the wave. I can pick big numbers to be at the bottom of the wave, in the middle, get everywhere on the wave. So what this would actually look like when you graph, and try to even put it on the graphing calculator. It's wild. I have to use the colored. So first of all, it's 0 here. But then between 1 and -1, okay, what will it look like? Well, over here, just a sine wave, but then it kind of like tapers off. X goes to infinity. Sine of really large numbers, sine of 0, so just 0, something like this. But over here, it just oscillates like crazy. It oscillates like crazy. What this means is that this sine wave is going like really crazy near 0. And what that means is that any value here, like pick any value, like, I don't know, 1 over rad 3. So I'll get oscillations of the sine wave that the y values are very close to 1 over rad 3, meaning this wave is approaching everything between negative and 1. I don't have one single y value that it's approaching. Like pick any y value that you like between -1 and 1. I can find you a bunch of small x values where the wave is hitting your favorite y value. All right. Like if you like 0.5, I'll give you a bunch of small x's where this sine wave is hitting 0.5 at those x's. So in terms of what the guy is doing, limit as x goes to 0 from the left. Well, first of all, let's do the easy one. Plot the guy, your hiker, to the left of 0 and make him go towards 0. What's his limit?
0.
0. Right. We don't care what happens to the right of 0. But limit as x goes to 0 from the right. I mean, this is probably the most sickening roller coaster ride you'll ever have, where you're going to be bopping up and down infinitely many times, approaching everything. Now, to be a limit, you have to approach one value. And this crazy sine wave is approaching everything.
Not limit.
So it's DNE. When you see something like that, it's DNE. Yeah.
Please explain the first one.
Oh, this one? Yeah, so limit from the left means that I have to plot the hiker to the left of 0, means he's standing here.
Yeah.
That's the first thing you guys have to do. Then x is going towards 0. So is the guy moving to the right or left?
Moving.
He's going towards 0. Where does he have to go? Right or left?
Oh, right.
He has to go to right. Right. Look where he's going. He's going towards 0. So what's his height? 0.
Oh, okay.
Exactly. You don't even have to look at what's happening here because his height is 0.
It's because the wave like didn't start.
The wave didn't even start. Yeah. Exactly. Yeah, you could even just try to graph it, but yeah, this wave is going an infinite number of times up and down within 0. Even impossible to draw accurately. But the idea is there's no like one y value that it's heading towards. That's what's going on. It's like a little oddball case. Jackie?
Does that also go for every input for sine? Or just
Um,
like one?
Oh, just when we're going towards 0. Yeah, just when we're going towards 0. So like, if you go away from 0, like you plug in large x values, 1 over large x values is small numbers, sine of small numbers is small. So then you could do stuff. But as soon as you start plugging in small numbers, then, try like 0.1. Then you get sine of 10. And you can do that on your calculator. Then try like 0.01, sine of 100, do that. They'll just be random. You'll put smaller and smaller numbers, 0.1, 0.01, 0.002, 0.003. You'll be computing sine of big numbers and there won't be any pattern. You'll just be computing, you'll just get a bunch of random numbers. And my claim is that when you do it like that, you'll just get random numbers. But in fact, any number between -1 and 1 is getting approached by this sine wave. Very close. Yeah, so let's say a number like 1.3, I can find a whole bunch of x values here, where the sine of those x values is 1.3, an infinite number of x values. Which just means it's oscillating infinitely many times. The strange, yes. Cosine, yes, same issue. That's right. It wouldn't matter. Cosine is just a shifted sine wave, so the same problem will just be oscillating like crazy.
What tangent?
With tangent, you should have the same issue. Yeah. We'll have same issue. Get random numbers. Um, Yeah, the way you can contrast what's going on is a little bit like here, where here there's a pattern because plugging in small numbers, the output 1 over x is really big numbers. And the numbers get bigger and bigger. We have a true pattern going towards infinity. Here, we're taking sine of big numbers and sine of bigger and bigger number. There is no pattern. It'll just keep oscillating. Yeah. Okay, so that's what picture like that means. Okay. Let's try a more standard one. Another example. Okay, so if you guys need to take a break, take a break. I'll do this one at 4:05. Take a break if you need to, but otherwise, see if you can compute those limits. Okay. It's a more standard one. And if you want me to check your work, also, you could raise your hand. I can check your work. If you have any questions. Yes, Rachel. Really worth very few points. I also dropped 2 quizzes, so it won't affect your grades.
Hey, what's wrong with this piece of shit?
Very happy old man to meet you.
I do.
So easy, but. Get this shit. Yeah.
Why is it negative?
Yeah. It's your own fault.
Yeah, classes you still can see it.
Where's Janice? Get Janice.
Okay.
I'm pretty sure we're doing lab. Like,
I would actually be worse. Baking is very good. Like really shine. The answer, but it won't let me put it in. Let me get a break. Okay, I didn't know.
What's your name? Matthew? Matthew T. Yeah, Matthew. Want me to check it? Sorry. That is right.
Okay.
Okay, so did you guys get, X goes to -2 from the left. So from the left, what are the Y values doing? They're going towards 5. Now, from the right, we look at -2 from the right, we look at the Y values. What are the Y values doing? They're going towards 1. Do they match?
Oh.
No. So what do we write? DNE. Okay. F of -2, we're looking for a closed circle. That's where the function is defined. F of -2 is 5. Yeah. Okay. Who got that? Yeah, raise your hand if that made sense. Okay, who's still a little iffy on these limits? Okay, any questions on these? And we'll do some more, but you guys see how we're doing. You're gonna have to, just use your finger to look at the Y values. Just, you have to place your finger at the right spot. So how do you know where to place it? Well, you look at the bottom, so -2 from the left. So you have to put your guy to the left of -2 on the graph, on top of the graph. And then look at what happens to his y values as he goes towards -2. It's a little bit, takes some time getting used to. But you're basically predicting, if you're looking at just his y values to the left of -2, what's the pattern of his y values, right? The pattern of his y values are going towards 5. Okay, so let's do something similar to the WebAssign. So try to draw down this function right here. Okay, so your WebAssign will have something similar to these piecewise functions. And once you have a piecewise function, you could start asking all these kinds of questions. So, limit as x goes to -8 from the left. Limit as x goes to -8 from the right. Limit as x goes to -5 from the left. Limit as x goes to -5 from the right. Okay. Limit as x goes to 0 from the left. Limit as x goes to 0 from the right. Okay, so at least try these at -8, -5, 0. And then limit as x goes to 5 from the left. Limit as x goes to 9 from the right. Okay, so take a moment, see how many of these you can get. So each one. Do each one separately. So -8. -5.
Bisa kali saya auto. Masa algoritmus pasti lagi. Oh, iya seperti itu. Langsung belajar. Yes.
Jackie? Check. What does this correspond to?
It's for -5. Negative. Negative.
Net -5.
From right side, it's my -1.
Exactly. That's right. From right side of -1.
Yeah,
That's right.
it does not match, and the result will be then.
That's right. The actual limit will be DNE, but none of those ask for that.
Ah,
They ask for the left, the
Okay.
right, but they don't ask.
Yeah,
But
yeah.
You're right. It would be DNE for that.
이익게 말았다. 그리고 -6 -1.
So you guys could, is there a question? Matthew?
Like, check,
What is it?
check what I-
Yeah, I'll actually go over, I'll go over it, so then we'll be on the same page. Okay, so let's do this one, guys. So -8 from the left. So again, those -8 from the left. What are the Y values doing? They're approaching
2.
2. Selena, that's what you're gonna, 2. -8 from the right. That means I'm -8, I'm looking at these Y values, they're getting close to 2. What about the, does the actual limit exist?
2.
Actual limit will be 2. That's right. Any questions? Is anyone still confused on how we did these limits? Right? All right, we're looking at the Y values from left and right. Have to picture like which direction you're going, the Y values. Depending on the direction you're going, but you're going towards -8 in the X. You're going towards -8 in the X, and you're looking at those Y values. -5 from the left is, Selena? 6. -5 from the right is, someone else want to try it? What's your primary name? Monica, yeah. -5 from the right, -1. Right. See, what about 0 from the left? Matthew T. Right, 0 from the left, the Y values are going towards infinity. Let's see. And then Sneha, what about 0 from the right? What did you get for that? -4, yeah, the Y value, 0 from the right, they're going closer to -4. Okay, what about the actual limit at -5? What would that be?
Does not match.
Rachel? Does not exist. Why? They don't match. Right, they have to match. What about this one, 0? DNE. Again, they don't match. Okay, what about 5 from the left? Go ahead.
My name is Luigi, and that's
Luigi?
right from the left is 4.
Okay, good. 5 from the left. It's going towards 4. Good. What about the right? 5 from the right would be
Same.
same thing. 9 from the right. 9 from the right is
3.
3. What about 9 from the left?
Same.
What's the actual limit?
3.
What's f of 3? I mean, what's f of 9? 3. They're all 3, right? You're not missing any information. So all the limits tell you is exactly what you know. That f of 9 is 3. Right? No, no gap to fill in, basically. Are we together, guys? Yeah. A little bit harder, but this is much closer to what you'll see on the website.
Mhm.
Okay, so just have these kinds of piecewise graphs, a bunch of questions. Okay, anyone still unsure? Like, you can even come up and start pointing on what's not making sense. Yeah. Okay, you'll get these conceptual WebAssign questions where they're asking you to work backwards. See, most of the questions are going to be, they give you the graph, and then they're asking you for the limit. Now, the conceptual question, which is much harder, it's really conceptual, is they're going to go the opposite way. They're going to give you the limit. Now, draw some graph that has those limits, right? So the way you could tell if you're really getting it is, can you go backwards of what we did? I gave you the graph, you guys gave me the limits. Can you go backwards? What if I gave you the limits? Can you draw for me the graph? Okay. Not as complicated as that one, but sketch any graph of f of x such that, let's say f of -2 is 5, f of 0 is -3, f of 3 is 4, limit as x goes to 3 of f of x is dne. And limit as x goes to -2 from the left of f of x is 2. Okay. Right, there's no one answer. There could be a million different answers. You could all come up with a different answer and all be correct. Okay. Just go backwards of what we just did. So now you have limits. Try to graph something that has those limits. Okay. So limit being DNE means left and right, something's not matching. Okay, let's start it, but I'm just curious, who thinks they got some of it? Okay. Was it tough? Which one tougher than the other ones?
It's in it.
I think you got the idea. Okay. Could be many different answers. Who thinks they could at least get f of -2 is 5? All right. Okay, good. Who thinks they can get at least f of 0 is -3? Okay, that's something. That's something. F of -2 is 5, so we should plot that. F of 0 is -3, so let's plot that. F of 3 is 4, so we should plot that. Okay. Now, the limit being DNE means left and right y values are not matching up. So a lot of different things you could do. You could just do like something here and like something here. Right? They're just not matching up from the left and the right. Right? Y values from the left are going to 4, y values from the right are going to some other y value. Okay. Should I color code it? So this part that matches that. Do you guys see that? You see how it's DNE? If I had them connected, it would not be DNE. Limit x goes to -2 from the left is 2. So if you guys want to draw that, the y values are going towards 2 and the x values are around -2. So you could draw something like that. Then the limit as x goes to -2, the y values are approaching 2. You guys see that? How the y values are approaching 2. Okay. So you could all be right with different answers, just as long as they match this. So just watch out on the WebAssign. I think WebAssign is like multiple choice with like 4 answers. And when you have multiple choice with 4 answers and 100 tries, everyone tends to get it right. You know, you just click submit. It's wrong, click submit. Please don't do that. Right? An exam will not be multiple choice. An exam will have you actually do this. So please don't click submit until you get it right. The point is to learn how to do these. Okay, so don't take advantage of that. Okay, any questions on this? So this makes sense. You see what I mean to go backwards? Okay, draw your own graph that matches. Okay. You could actually do something clever. I saw someone do something clever. And it's fully acceptable. It's totally right. They just didn't draw this at all. They drew nothing here. And this is actually right. Anyone see why this is right? If I drew nothing here. Jackie?
Because nothing from the other side approaches it,
What is it?
because nothing on the other side approaches.
Yeah, exactly. Because limit technically means I have a pattern left and right. So if I have nothing going on the right, I'm DNE by default. By default, there is nothing to see on the right. So it's already automatically DNE. Technically, that would be right by drawing nothing. Pretty cool. Yeah. Okay.
Yeah, it's okay. Yep.
Okay. Also in this section, we already saw these infinite limits where the y values are going towards infinity. Okay, so we could make it formalize this a little bit. Right, it's not a new section, it's all part of this section. So the infinite limits. F of x is equal to f of x minus 3. Okay. So again, what's the domain? X is not equal to 3. If we draw this, it's very similar to what we had. What would it look like? It would look something like this. Something like that. Okay. How did I draw it so fast? Remember that trick I said? If you know the graph of 1 over x, then you could just shift it. Here I shifted it by 3, so that's how I drew it so fast. Yeah. Okay, so if you look at the graph, limit as x goes to 3 from the right of f of x. Notice that as x goes to 3 from the right, the y values are heading towards what's happening to them? Positive infinity. If I look at the graph, the y values are heading towards negative infinity. Could I train a computer to figure it out? Yeah, the way you would do it is you just plug in values close to 3. So x and f of x, you'll get, if you plug in 2.9, the output is negative 50. If you plug in 2.99, the output is negative 500. If you plug in 2.999, the output is negative 5,000. That if you plug in 2.9999, the output is negative 50,000. Okay. What are the y values doing as x goes to negative 3 or x goes to 3 from the left? Y value, what's the pattern of y values?
And reach infinity.
Right, they're going to negative infinity. So it's exactly this thing. Two ways to see it. I could see it with a graph. I could see it with a computer just by plugging in values very close to 3, that the pattern is negative infinity. Okay. Once you have this, if one of these limits, you don't need both, actually just one. You've learned this in pre-calculus, but here's the real definition, is if one of these limits is infinity or negative infinity, we say
Does not match.
x equals 3 is a vertical asymptote. I guess VA, abbreviate vertical asymptote. So that's what it means. X equals 3 is a vertical asymptote. We think of a line, x equals 3 as a vertical asymptote, where on the left or right, the function is blowing up,
Okay.
right? That's the official math term. It's really called blowing up. Look at math books, they'll say blow up instead of infinity or negative infinity. Yeah, the y values are going towards positive or negative infinity on the left or right. That's what a vertical asymptote is. Okay, first of all, do they match here? No. So if WebAssign asks you what's the limit as x goes to 3, the answer is
Hey,
D and E.
cool.
Okay, now the tricky part about these is the problems that you guys are going to get, they're not going to be a graph. They're not going to be a calculator like this. They're just going to give you a function, and you have to figure out if you have an infinite limit. Okay, so here's how you could figure it out. You could actually, even without graphing, we could figure out negative infinity and infinity just doing algebra. There's an algebra way to do it. So that's what we need. So we call these kind of limits, I'll call them the C/0 case. The C/0 case is when C is not 0. Okay, so what's going to happen is in the C/0 case, your function is going to be like one function over another, like g1 of x, g2 of x. And you might want to do the limit as x goes to a from the left of g1 of x over g2 of x. Okay, so even without graphing it, I could figure out if I have an infinite limit. So just plug in the value. Just plug in the value a and check if your denominator becomes 0. So the trick, just plug in A. Just plug it in, even if it doesn't make sense, right? That's why it's a trick. Tricks don't have to make sense, right? We'll just justify this trick. Just plug in A. So you're going to compute G1 of A and G2 of A. So you're just going to plug it in. And suppose your numerator is C and your denominator is 0. But C is not 0. So what's happening is that near A, so at A, you get something crazy, which is C over 0. But what's really happening is that when you're close to A, your denominator is super tiny and the numerator is not. So what happens in algebra if your numerator is some number and you're dividing it by something super tiny?
Big number.
It's getting big numbers or small numbers? Big, really big. So if your numerator is becoming 0, that means that this has to be plus or minus infinity. One or the other. We don't know which one yet, but it will be one of them. Okay. So let me show you how this trick works. So g of x is equal to 1 over x plus 1 squared. Compute limit as x goes to -1 to the left. Okay. Let me just write down, put the function here. Okay. How is this going to work? You're looking at the x value -1. Let's just pretend we could plug in -1. If we plug in -1, what's our numerator? 1. What's our denominator? 0. Okay. So we're getting a numerator. That means for x values that are near -1, we're getting a numerator close to 1 divided by a denominator that's almost 0. That means we're blowing up. So the answer is plus or minus infinity. We already know it has to be plus or minus infinity. The pattern here has to be a blow up with the denominator going to 0 like that. If the numerator is 0 and you have 0 over 0, you can't use this trick because 0 over 0 we'll see is actually the trickiest thing to deal with. But as long as the numerator is not 0, but the denominator is being 0, your answer will be one of these. Let's see. What?
Why is it a 0?
What is it?
Why is it a 0?
Oh, why is it 0 here? Oh, just plug in -1. So this is 1 divided by -1 plus 1 squared. And what's -1 plus 1? It's 1 over 0. Okay. So you could solve this just by intuition. It's plus or minus infinity. How do we decide if it's positive or negative? Right? We know the answer is one of these. We just don't know which. The way you decide is just test any value in the limit. Just test something to the left of -1. If you get something negative, then you'll choose negative. If you get something positive, you'll choose positive. So test. Just give me any number close to -1, but to the left. What could we test? Go ahead, Matthew T.
The left is -1,
Okay. Test x equals, yeah, the left of -1.
-2.
-2, that'll work. You could even do -1.1, but -2 is fine. So 1 divided by -2 plus 1 squared, will that be a positive or a negative number? It could be a positive number. You don't care what the number is, so I won't even write it because it doesn't matter. So it's positive, so we know it's going to be plus infinity. The answer is plus infinity. Okay. You don't have to graph it. You don't need your calculator. You just have to plug it in and see if you get something over 0. Because a non-zero number divided by something getting close to 0 is blowing up. It's going to positive or negative infinity. Which means that at -1 to the left, we're going towards plus infinity. It has to look something like that. Okay, it has to look something like that. Try to the right. Limit as x goes to -1 to the right. 1 over x plus 1 squared. So plug in -1 first, make sure that you have c over 0. Okay. So you know the answer has to be plus or minus infinity. And then test something to the right to figure out if you should use a plus or a minus sign. Okay. If I plug in -1, what do I get? Yeah, Layla? 1 over 0. Right, so this part's important. So you're going to write 1 over 0, and then you could write plus or minus infinity. That's how you show work. So if I see 1 over 0 and you decided plus or minus infinity, I know what you did. I understand what that means. Okay, good. But then Layla, how did you decide which sign to use?
0 because we're looking for the number for -1 from the right.
Good. We're looking for -1 to the right. We plug in 0, and what do we get?
1 which is positive, so it's positive.
Positive. Yeah, so it's positive infinity. Good. Layla's saying. Just plug in a number to the right, then you'll know what's happening. Right? Because you're testing for pattern. You already know it's going to blow up. You just need to figure out if it's blowing up positively or blowing up negatively. If you really want to make sure like something doesn't mess up, you can plug in a decimal to the right, like 1 over -0.9 plus 1 squared. Doesn't matter what the answer is, as long as we know that it's positive. So we pick positive. So when we graph it, that means that it's also going to positive infinity from the right side. The right side is also. Okay. What about the actual limit? What if it asks you for the actual limit? What do we write, Rachel? Right, positive infinity. Because why? Do they match? Because of matching. Again, limit means a matching. That's all a limit actually means. Squared, positive infinity. And again here, because as you don't need both of these limits to be positive or negative, but as long as one of them, that means that x equals -1 is VA, vertical asymptote. And that's what it means to be vertical. Function is blowing up either to the left or to the right of the vertical line. Okay. So as long as one side is blowing up. Let's do another example. Try this one. Limit as x goes to 5 from the right, x squared plus 7x, x squared minus 25. Limit as x goes to 5 from the left, x squared plus 7x, squared minus 25. Okay. So try the trick, right? The trick is you could just plug in 5 first, and if you get a c over 0 type thing, you already know you're positive or negative. Okay. Positive or negative infinity.
Positive image. Everything will should вести предела соответственно значит плюс as the infinity тоже нет. Если x
Okay. If I plug in 5, what do I get? What's the numerator?
as the infinity
Numerator is 60. What's the denominator? 0. So that means near 5, the numerator is near 60, but the denominator is going towards 0. So a non-zero number divided by 0 is blowing up, plus or minus infinity. Has to be one or the other. How do I figure out which one?
as
Yeah, go ahead. And is it Ronaldo? What's your name?
Although, yeah.
Ronaldo? Okay. Yeah, go ahead. How do we figure it out? I need to know if it's plus or minus.
have to take like 5.1
Yeah, let's see, Josiah?
Yeah.
Oh, tell me your name?
Becca.
Oh, no, behind you, sorry. Yeah, go ahead.
Cameron.
Oh, Cameron. Yeah, Cameron. Yeah, go ahead.
So I'm just give you the answer first and then explain. So it'll be positive infinity.
Positive infinity. How did you decide that it's positive?
Because looking at the numerator,
Yeah,
you can see that x squared. When you see the number, when I think of the number x squared and compare it to 7x, x squared,
Yeah.
at a certain point will be greater than 7x, which means that it will keep increasing.
but that's true. That's true. The true numerator is positive, but the denominator might be negative. Yeah. So remember, we're looking at y values of the whole thing. Y values of the whole thing. So there won't be any shortcuts, guys. You will have to test something to the right of 5 like we did. So let's think of something to the right of 5. Let's say 5.1. 5.1 squared plus 7x plus 7 times 5.1 divided by 5.1 squared minus 25. Is the numerator positive or negative? Positive?
Yeah.
Well, 5.1 squared, is that bigger than 25?
Yeah.
Yeah, so the denominator is positive, right? So we're getting positive, right? No shortcuts. You guys have to do this. Otherwise, you'll leave points. Otherwise, I'll know you're guessing. The only way you could figure out that it's actually positive infinity. Okay. Yeah, Cameron, does that make sense? Because you're right about the numerator, but the denominator could have been negative though. And we'll see the next problem, the denominator will be negative. So 5 from the left, if we plug in 5, what do we get? Again, we get 60 over 0. So that means the answer could only be positive or negative. How will we decide which sign? Right? We should test which number?
4.9.
4.9, sure. 4.9 squared plus 7 times 4.9 divided by 4.9 squared minus 25. 4.9 squared bigger or less than 25? Less, so the denominator is negative. Negative. Right, so the answer here is going to be negative infinity. So the answer here is negative infinity. Rachel?
9 and like 5.1 stuff, but is that okay if we use whole numbers to plug in?
Yeah, I'll go with it. If you want to do that, sure. Yeah, there is a way to like make these pathological examples where whole numbers won't work, but since you won't see that, it's okay. Oh yeah, what's the vertical asymptote here? Yeah, it's negative and positive 5. We do know positive 5. 5 is vertical, is a VA. And the reason you're saying -5 is because if x is -5, we also get c over 0. We get a 0 denominator.
That's true.
What's the actual limit? X goes to 5.
Then I
dne y
does not much.
does not match. Yeah. So limit as x goes to 5, x squared plus 7x, x squared minus 25. That's going to be dne. Does that make sense, guys? You how to do that? Okay. So try. Let's see. Let me give you. I'll just write down the answer just so you see. When WebAssign gives you these oddball ones. WebAssign, for some reason, they do like to test you on trig. So you will have to know a little bit of trig. If you plug in pi halves, you'll get pi halves divided by cosine of pi halves. Cosine of pi halves is 0. So you do have to keep that in mind. So don't get confused by that. So it will be plus or minus infinity. Again, how will you decide? Plug in something a little bit bigger than pi halves. So you could even do it graphically.
Yeah.
Something a little bit bigger than pi halves, cosine is negative. Then this whole thing will be negative. It'll be negative infinity. If you didn't see that graphically, you know, you could just, you could have done it with your calculator, plug in something a little bit bigger than pi halves. We'll pause here, guys. Good weekend. See you next Monday. Anyone has questions? So I'll stay a little bit. Ask any questions. Yeah, you need papers? Yeah.
No.
I have a degree online, but that's about it.
And that's that.